Good morning, students.
Good morning, ma'am.
Okay, good morning. All of you, please switch on your videos. Now, last class we derived the expression for law of sine, but we didn't complete it. So once again, I am going through each steps in order to derive the law of sine. So I think in the last class we missed one step. So you just listen here where we are made that mistake and try to rewrite that equations once again. So once again, we are going to derive the equation for law of sine. Law of sine. So in order to derive an expression for law of sine, here we consider the same figure. That is, we consider the two vectors, vector P and vector Q, with the magnitude P and Q respectively. If they are representing the two adjacent sides of a parallelogram starting from the same point, then the parallelogram law of vector addition, we know that the resultant is the diagonal of the parallelogram. The resultant vector is the diagonal of the parallelogram. All the other conditions will be the same. And in order to derive the expression for or find out a magnitude and direction of the resultant vector, here we are made an extension to this OA and draw a line that is perpendicular to this OA, and this is coincide at this point D. And this vector P and vector Q is inclined at an angle theta. So we can consider this angle also will be equal to theta. And this side BA is exactly parallel to that of OC. So here it is also represent vector Q. This side is also represents vector Q. Here it is vector P. Then in order to derive an expression for law of cosine, we start the derivation by consider an angle between vector P and vector R as alpha. Okay. So all these things that we are discussed in the second case, that is while we are deriving the expression for law of cosine. So today we are going to start the derivation for the law of sine. Once again, kindly go through each steps and find out where we are made that mistake. I think one step I missed from this derivations. Okay. So in order to derive an expression for law of sine, here we consider some cases. We draw a line that is perpendicular to the resultant vector. Draw a line perpendicular to the resultant vector, and it is coincide at this point. We give a name to this point as E. So here we have so many triangles, like triangle OAE, triangle ABE, triangle ABD, and one a large triangle, triangle ODB. Okay. So here we draw a line, perpendicular line from the point A to this resultant vector and mark that point as E. So now we are going to start the derivation. In order to write an expression for law of sine or find the expression for law of sine, here we consider an angle beta between the resultant vector and the vector Q, that is here. Here we consider an angle, or here we choose an angle beta between the resultant vector R and vector Q. So as we told earlier, the angle between vector P and vector Q, angle between vector P and vector Q is theta. Similarly, the angle between vector P and the resultant vector R is taken as alpha. Angle between vector Q and the resultant vector is taken as beta. So while deriving an expression for law of cosine, we are considering an angle between vector P and the resultant vector R. But here we are going to derive an expression for law of sine. For that, here we consider an angle between vector Q and the resultant vector R, and it is taken as beta. Okay. Now, We consider the triangle ODB. We are starting with the triangle ODB. Consider the triangle ODB. From triangle ODB, what we are calculating from the triangle ODB? We are repeating the same topic here that we are discussing in the last class. We are considering the triangle ODB. From triangle ODB, what we are calculate? Which angle we are consider? S Malaviga? Sine alpha. So from triangle we are find out sine alpha. We know that sine alpha is equal to opposite side divided by hypotenuse. Opposite side divided by hypotenuse. This is the general expression for calculating the sine alpha. From the figure we get sine alpha is equal to, what is the opposite side here? Opposite side of the triangle ODB. Here we have alpha. So opposite side is BD. Okay. And what about the hypotenuse? Hypotenuse represented by OB. What is the value of OB? R. So sine alpha is equal to, we get BD divided by R. Sine alpha is equal to BD by R, which implies BD is equal to R sine alpha. This is our equation number 1. Now we are going to consider the second triangle, triangle ADB. Next triangle, triangle ADB. I think we are not take this triangle in the last case, right? Did we consider the triangle ADB? No. So the second step we need to consider the triangle ADB. Triangle ADB. The small triangle of this figure. Triangle ADB. From triangle, which angle we can consider? Which angle is present in triangle ADB? Angle theta. So here, from the triangle ADB, we are going to find out sine theta. Sine theta. Consider the triangle ADB. From triangle ADB, sine theta is equal to, again the same equation, opposite side divided by hypotenuse. So from the figure, try to say what is opposite side here. From triangle ADB, opposite side divided by hypotenuse. The angle theta is here. BD, hypotenuse AB. So here from the triangle ADB, opposite side is BD divided by AB, or we can substitute the values. Sine theta is equal to BD. We don't know the value of BD divided by AB. What about the value of AB? Q, which implies BD is equal to Q sine theta. BD is equal to Q sine theta. This is our second equation. So here we get two equations for BD. From the first equations we have BD is equal to R sine alpha, and from the second equation BD is equal to Q sine theta. Now we can consider the third triangle. Which is our third triangle? Consider triangle OAE. I think that is one of the inner triangle. Triangle OAE. This one. Here we have again alpha. Sine alpha is equal to triangle alpha. So here a triangle OAE. From this triangle OAE, we have sine alpha. Sine alpha is equal to opposite side divided by hypotenuse. We already find an expression for the sine alpha from this triangle. What is that? Sine alpha is equal to, what is the opposite side here?
A.
AE. And hypotenuse?
OA.
OA, what is its value?
P.
P. AE divided by OA, that is sine alpha is equal to AE divided by P, which implies AE is equal to, bring this P to the LHS, it becomes P sine alpha. P sine alpha. This is our equation number 3. Here we want to consider one more triangle. What is that? Triangle ABE. Consider triangle ABE. Consider the triangle ABE. All of you take the figure and consider the triangle AB, the next inner triangle. ABE here. Which angle is present here? Beta. So here we calculate all the sine angles. So here we want to calculate sine beta. Sine beta. From the triangle ABE, sine beta is equal to, again the equation, opposite side divided by hypotenuse. Or we can write sine beta is equal to, what is the opposite side here?
AE.
AE, hypotenuse.
AB.
AB, what is its value?
Q.
Q. So it becomes sine beta is equal to AE divided by Q. Sine beta is equal to AE divided by Q, which implies AE is equal to Q sine beta. This is our fourth equation. So here we consider the same figure, but we make some rearrangements in this figure in order to derive an expression for law of sine. That is, we draw a line from this point A to this resultant vector and mark that point as E. And we consider the angle between this vector Q and the resultant vector R as beta. Then we consider all the triangles that is present in this equation with the sine angle, in terms of sine angle. Here we have the triangle OAE, then the inner triangle ABD, then triangle ODB, and one more triangle, triangle ABE. So here we consider these 4 triangles and find the sine angles from all these triangles. So that is what is here we are doing. So after that we get the expression for BD is equal to R sine alpha. This is our first equation. Then BD is equal to Q sine theta from the second triangle. This is our second equation. Then AE is equal to P sine alpha, the third equation, and it is obtained from the third triangle. And then AE is equal to again Q sine beta. This is our fourth equation. So the next step, here we are going to compare the equation 1 and 2. So that is our next step. compare equation 1 and 2. Equation 1 and 2. So here once again I will rewrite the equations 1 and 2. According to your equation 1, here we have BD is equal to R sin alpha. This is our first equation. Again from second equation we have BD is equal to Q sin theta, right? From our first equation we have BD is equal to R sin alpha, and from the second equation we have BD is equal to Q sin theta. So what about the LHS of these equations? LHS are same. From the first equation we have BD is equal to R sin alpha, and from the second equation we get BD is equal to Q sin theta, right? So here we are going to compare these two equations. BD is equal to R sin alpha and BD is equal to Q sin theta. By comparing it, we observe that, or we conclude that the LHS of these two equations are same. So we can write R sin alpha is equal to Q sin theta. By comparing these two equations, we can write R sin alpha is equal to Q sin theta. Now by rearranging the terms, we are going to bring the sin theta to LHS and sin alpha to RHS. So it becomes I want to bring the sin theta from RHS to LHS. So it becomes, yes, it's right. Unmute and say.
Negative sin theta.
Is it negative? Here it is multiplication. Q into sin theta. Division. So here I want to bring the sin theta from RHS to LHS. So it becomes R by sin theta. R by sin theta is equal to Q by sin alpha. I am bringing this sin alpha term from LHS to RHS. So by comparing the first two equations, we get BD is equal to, we get two equations for BD. One is R sin alpha and other is Q sin theta. So we just equate these two equations. So we get R sin alpha is equal to Q sin theta. By rearranging this equation, we have R by sin theta is equal to Q by sin alpha. Okay, so this is our equation number 5. Equation 5. Now the next step, compare the equation 3 and 4. Compare equation 3 and 4. Students, once again, can you recall equation number 3? What is equation 3?
A is equal to P sin alpha.
A is equal to P sin alpha. Then this is our equation number 3.
Q sin beta.
A is equal to Q sin beta. This is our equation number 4. Here we are going to compare this equation 3 and 4. Again, from this equation 3 and 4, the LHS of these two equations are same. So we can equate the equations 3 and 4. So by equating 3 and 4, we get P sin alpha is equal to Q sin beta, because their LHS are same, both are equal to AE. So here we can equate these equations 3 and 4. So it becomes P sin alpha is equal to Q sin beta. Here also we can rearrange the equation by interchanging the sine angle terms into LHS and RHS. By rearranging, we have P by sin beta. we take the sine beta terms to LHS, and now we are going to take the sine alpha term to RHS. So P by sine beta is equal to Q by sine alpha. This is our equation number 6. So P by sine beta is equal to Q by sine alpha. So here we get two new equation, equation number 5 and equation number 6. What is our equation number 5? R by sine theta is equal to Q by sine alpha, right? R by sine theta is equal to Q by sine alpha. This is our equation number 5. What is our equation number 6? P by sine beta is equal to Q by sine alpha. P by sine beta is equal to Q by sine alpha. This is our equation number 6. So what is the speciality of this equation? Is anything is common? R by sine theta is equal to Q by sine alpha. P by sine beta is equal to Q by sine alpha. What is this indicates?
By sine beta is equal to B by sine beta.
Yes, from this equation number 5 and 6 here we can say that both R by sine theta and P by sine beta is equal to Q by sine alpha. So from the equation 5 and 6, from equation 5 and 6, we can say R by sine theta is equal to P by sine beta, and this R by sine theta and P by sine theta is also equivalent to Q by sine alpha. This equation is known as law of sine. This equation is known as law of sine. So actually these derivation steps are not at all important. At least you try to study the final equation. R by sine theta is equal to P by sine beta is equal to Q by sine alpha. So if you know the values of angle, then you can easily calculate the magnitude of the vectors R, P and Q respectively. This is known as law of sine. Law of sine. So R by sine theta is equal to P by sine beta is equal to Q by sine alpha. Actually, the method is simple if you are conscious about that of these triangles. So here we have consider the 4 different types of triangles and we calculate the sine angle functions from each these 4 triangles. Whenever we get the equations, it is easy. We just combine the equations and rearranging it. So we get an expression for Q by sine alpha and then equate it. Finally, equate all these equations. So we get R by sine theta is equal to P by sine beta is equal to Q by sine alpha. This equation is known as law of sine in vector addition using analytical method. So under addition, vector addition using analytical method, we discussed the 2 laws. One is a law of cosine. Did you remember the law of cosine? Abhinav? Law of cosine is mainly used to find out the magnitude and direction of the resultant vector R. Mary Angelina, what is the equation for calculating the magnitude of a resultant vector using law of cosine?
Ma'am, R by sine theta equal to P by sine beta equal to Q by sine alpha.
Wow, that is law of sine. My question is law of cosine. Law of cosine.
Ma'am, R equal to root of P square plus Q square plus 2PQ cos theta.
Yes, very good. R is equal to root of P square plus Q square plus 2PQ cos theta. Okay, so it is not needed to become P and Q. It depends upon the vectors that we are consider. So here we are consider the two vectors as P and Q. Instead of this P and Q, you can consider any vectors. You can take any letters, any alphabets. It can be either A and B. Then the equation becomes R is equal to root of A square plus B square plus 2AB cos theta. Similarly, here instead of this P, Q and R, you can take A, B, C. If P and Q, instead of P and Q, if you are taking it as A and B are the vectors with the magnitude A and B, and the resultant vector is C, so the equation become C by sin theta is equal to A by sin beta is equal to B by sin alpha. Okay, so it is not compulsory to take these vectors as P and Q. You can take any letters as your vectors. But the general form of the equation will be like this. The resultant vector, magnitude of the resultant vector with the R by sin theta is equal to P by sin beta is equal to Q by sin alpha. And this equation is known as law of sine. Is it clear?
Yes, ma'am.
Okay, all right. So here we have three different methods of vector additions are there. Can you recall what are the three different methods? The first method that we had already discussed is vector addition using graphical method. We have three different methods are there for add the two different types of vectors. If we have two or more vectors, we have three different methods are there. The first one is graphical method. Under graphical method, we also consider the two laws. One is triangle law of vector addition and the other is the parallelogram law of vector addition. The second method of vector addition is known as analytical method. Under the analytical method also we consider the two laws. One is law of sine and other is law of cosine. Law of cosine and law of sine. Now we are going to discuss the third method of vector addition. What is the third method of vector addition?
Component.
Yes, vector addition using component method. So that is what we are going to discuss today. Vector addition using component method. Okay. So actually this vector addition using component method is exactly similar to that of analytical method of vector addition. Mainly we have three methods are there: graphical method, analytical method and component method. Component method of vector addition is exactly similar to that of analytical method, but we are carried out this component method of vector addition in a different pattern or different format. A different format is there for vector addition using component method. That is, here we consider the vectors in the form of components. So if we know the vectors in the form of components, then you can easily add the two vectors. But before that, first of all, you should know what you mean by component form of vectors. If you have an idea about the component form of vectors, then you can easily add the vector addition using component method. So for that, it is better to understand another term in physics, that is what is known as resolution of vectors. Okay, so in your textbook you can see a topic, resolution of vectors. Actually this topic is indicate in order to create an idea about component form of vectors. If and only if you have an idea of component form of vectors, then only we can perform the vector addition using component method. So before entering into the topic vector addition using component method, we are going to discuss resolution of vectors. Okay, so if you get an idea about the component vectors, what you mean by component form of vectors, then only you can employ the method of these vector addition using component method. So for that, we are going to describe another topic in physics, that is what is known as resolution of vectors. So first of all, we can discuss what you mean by resolution of vectors. After that, we can enter into the third method of vector addition by component method. So all of you write the next heading, resolution of vectors. Resolution of vectors. you mean by resolution of vectors? Resolution of vectors. By this term resolution of vectors, we mean that we can split any vector into two or more different components. Okay, suppose students, you just listen here. We have, this is our vector A. And this resolution of vectors is possible if and only if these vectors are inclined at an angle theta. So here we have the vector A. Here we have vector B. Then according to triangle law of vector addition, what is the resultant vector here? No idea. State the triangle law of vector addition. Here we have two vectors, vector A and vector B. They are arranged like this. They are from the same order. Then according to triangle law of vector addition, what is the resultant vector here? Where we can represent the resultant vector? Unmute and say. Yes, John Philip.
Ma'am, tail of resultant vector on head of vector B and head of resultant vector on tail of.
Okay, and how it is represent? The resultant vector is represents the which side of the triangle?
Third side triangle.
The third side of the triangle. So here the third side of the triangle gives the resultant vector and which is taken in the opposite order. So that is what is according to the law of triangle law of vector addition. And here this capital A is represents the third side or the resultant vector of these components, vector A and vector B. So here we have a main vector or a large vector, vector A, and we can say that this vector A is the sum of vector small a and that of vector B. So here we can say vector A is the sum of vector A plus vector B. The resultant vector, vector A is the sum of vector A and vector B. Or we can say vector A and vector B, small letter vector A and vector B are the components of vector capital vector A. Small letter vector A and small letter vector B are the components of capital letter vector A. Okay, so here we are divide or split this main vector, vector A into two small components. That is, one is small vector A and other is small vector B. Again, the division is possible. You just imagine I further divide this vector B. Here I consider another vector C and then consider another vector D. So what is vector B here? Vector B is the resultant vector. It is the sum of the two vectors. What are the two vectors here? Vector B is the sum of the two more vectors. What are they? Yes, it's right. Vector C plus vector D. Right? Here the vector B is the sum of the two vectors, vector C plus vector D. So our equation becomes vector A is equal to small vector A plus, instead of B, here we again further divide this vector B into smaller terms. That is vector C plus vector D. So the same vector A is again divided into three components. In the first case, we are divided it into two components. Now in the second case, we divide it into three components. Okay, children, now it's the time. We can continue in the next period.